Hello math learners, Hassan here, back on this Algebra One adventure with you. In this tutorial, we are diving into the properties of real numbers. The properties of real numbers are fundamental principles that govern the behavior of numbers in mathematical operations. Understanding these properties is crucial in various branches of mathematics, including algebra, calculus, and geometry. So let's begin. Okay, so let's start. Here are the main properties of real numbers. First of all, we have commutative laws. The commutative property of addition states that numbers may be added in any order without affecting the sum. So if we add a and b, a plus b is same as b plus a. For example, if you see 6 plus 3, which equals 9, is same as 3 plus 6, which equals 9 as well. We have the commutative property of multiplication as well. This law states that numbers may be multiplied in any order without affecting the product. So we can multiply a times b, which is same as b times a. For example, here 2 times 4, which equals 8, is same as 4 times 2, which equals 8 as well. So to conclude, we can see that commutative property can be applicable to both multiplication and addition, and we can swap numbers and we still get the same answer. Up next, we have associative laws. The associative property of addition tells us that numbers may be grouped differently without affecting the sum. For example, if we add 6 plus 3 over here, that equals 9. And now if you add 4, 9 plus 4 equal 13. Now, if you group the numbers differently, 3 plus 4 equals 7. 6 plus 7 equal 13 as well. This is how the associative property of addition is applied over here. Next, we have associative property of multiplication, which tells us that it does not matter how you group numbers when multiplying. We can have 2 times 4, that equals 8. 8 times 3, that equals 24. Now, if you change the grouping, 4 times 3 equals 12. 2 times 12 equal 24 as well. We can see that the associative property is applicable when we add or multiply. Up next, we have distributive law. The distributive property states that the product of a factor times a sum is the sum of the factor times each term in the sum. Let me explain this with an example. If we have a sum b plus c and we want to multiply a with this sum, this is what we call the distribution. Now to distribute this, we want to distribute a with b and also a with c. So we have a times b plus a times c. Now if we look at this example, we have 12 plus negative 7 and we want to distribute this 4 with each of the term in the parentheses. So we have 4 times 12 plus, this plus comes from here, 4 times negative 7. So if we add them, 4 times 12 is 48 and 4 times negative 7 is negative 28. So if we add, it's 20. Now, if we don't do this distribution, let's see what we get. 4 times 12 plus negative 7 is 5. So 4 times 5 is 20. This shows that both steps give the same answer. Now we can also apply a special case of the distributive property when the addition of a negative number is changed into subtraction. Over here we can see that we are adding a negative number, but we can distribute this sign and get a subtraction. So for example, if we add 6 plus negative 4, we can write this as 6 subtract 4, which ultimately gives 2 as the answer. So keep in mind moving forward so you can apply that in the practice problems. Now, I want to share another important note that when you describe this distributive law property, we say that multiplication distributes over addition. The reverse is not true. We don't distribute addition over multiplication. For example, we have 6 times 204 and we want to break this 204 into 204. So we are basically distributing the multiplication over addition. So 6 times 200 is 1200 and 6 times 4 is 24. Now 6 times 204 is 1224, which means both sides match. But if you want to distribute the addition over multiplication, let's see what happens over here. So let's say we have 6 plus 3 times 5 and we want to distribute this 6 with 3 and 6 with 5. So we get 6 plus 3 times 6 plus 5. Let's see what happens over here. So 6 plus 3 times 5 is 15. So 6 plus 15 gives you 21. And 6 plus 3, which equals 9. And 6 plus 5, which equals 11. Now we multiply 9 and 11 give 99. We can see that we cannot distribute addition over multiplication. So 21 is not equal to 99. This proves that multiplication distributes over addition in the distributive law. Next, we have identity property. Now we have identity property of addition, which states that there is a unique number called the additive identity 0 that when added to a number results in the original number. So if we add 0 with a, it gives a. Then we have identity property of multiplication. This states that there is a unique number called the multiplicative identity 1 that when multiplied by a number results in the original number. So if you multiply 1 with any number, it gives that number. So a times 1 is equal to a. So to conclude, adding 0 leaves the real number unchanged. Likewise for multiplying by 1. So if you add 0 with any number, we get that number. And if you multiply 1 with any number, we get that number. This is the identity property. Up next, we have inverse property. For addition, the inverse of a real number is its negative. So if you have any number, its additive inverse is the negative of that number. So if you have 6, the additive inverse is negative 6. So if you add these two numbers, it comes down to 0. For multiplication, the inverse of a real number is its reciprocal. So if you have any number, we just take that reciprocal to get the multiplicative inverse. So for 6, the multiplicative inverse is 1 over 6. And if you multiply these two numbers, we get 1. Let's see an example with a fraction. So for multiplication, we know that if you multiply a number and its reciprocal, we get 1. If you have negative 2 over 3, how can I take the reciprocal of this negative 2 over 3? So reciprocal is 1 over negative 2 over 3. We are dividing 1 by negative 2 over 3. So this denominator would come at the numerator. So we have negative 3 over 2. So the reciprocal of negative 2 over 3 is negative 3 over 2. If you multiply this negative 2 over 3 and negative 3 over 2, we get 1. So you can see that these 3 cancel each other out and these 2 cancel each other out. Negative times negative is positive 1 over here. So it comes down to 1. Now the last note is we cannot apply this multiplicative inverse for 0 because 1 over 0 is undefined. So if we have a 0, we cannot have its inverse as 1 over 0 because this 1 over 0 is undefined. So this is an exception in this case. Keep that in mind. Okay, zero product property, which means multiplying by 0 gives 0. We can see that if you multiply any numbers by 0, we'll get 0. So a times 0 or 0 times a will be 0. This is applicable to any number. 5 times 0 or 0 times 5 is 0. Now this is also applicable to 0 as well. 0 times 0 is also 0. Now the division by 0 property states that if you divide any number by 0, it gives an undefined response. So anytime if you have a division by 0, we have an undefined response. Now we'll see some practice problems over here. Now let's try to solve these problems over here. It says match the appropriate property with the correct example. So number one, we have 4 plus 5 plus 6, and that is equal to 6 plus 4 plus 5. We can see that the numbers are in different orders. So over here we can see that we have 4 plus 5 over here, and the 6 is right there. But here 4 plus 5 is right here, and 6 has been moved forward. So this property is known as the commutative property, which states that numbers can be added in any order without affecting the sum. So this should be B. The next one is A times 0 is equal to 0. So A times 0 is equal to 0. This is the multiplicative property of 0, because anything times 0 is 0. So this should be I. Number 3, we have 2 times 1/2 equals 1. So you can see that we multiplied 2 by its reciprocal, which gives 1. So this is multiplicative inverse. So we have D. Number 4, we have A times D equals D times A. Again, we can see that the order has been switched in this multiplication. So this is commutative property of multiplication, which is F. Number 5, we have open parenthesis 8 plus 2 close parenthesis plus 4 equals 8 plus open parenthesis 2 plus 4 close parenthesis. In this case, we can see that numbers have been grouped differently. So here we have 8 plus 2, but over here we have 2 plus 4. So this property is known as associative property of addition. So this should be C. So the associative property of addition says numbers can be grouped differently without affecting the sum. Number 6, we have 8 times 1 equals 8. Again, we can see that this is a multiplication. So this is a multiplicative identity property. So this is E. Number 7, we have 42 minus 6a equals 6, open parenthesis 7 minus a. So you can see that 6 has been taken as a factor. So this is a property of distribution. So this is known as distributive property. So this is G. Number 8, we have a plus 0 equals a. We can see that the sum has not been affected by the addition of 0. So this is an additive identity property. So this is A. So this is how we can classify the different properties, and knowing this would be helpful for the future lessons. Voila, that's it for properties of real numbers. These properties are your pals in the world of algebra, and knowing them is your superpower. And that's a wrap for today's video. I hope you enjoyed this topic. I'll catch you in the next one. Now let's get this study.